this video, I'm gonna go over just the general idea of invertible versus non-invertible systems. So just to go over the definition. So a invertible system basically follows the one-to-one mapping rule, which I'll go over in a second, between the input and output for every instant in time, for literally every millisecond to microsecond in time. Okay, so I'm gonna go over two things: one-to-one mapping and many-to-one mapping. It's pretty simple, but can get a little complicated depending on what is going on, or depending on what you plug in. But I'll give you the brief idea. So this is one-to-one mapping. So let's say this circle represents x of t, and this circle represents y of t, and let's say you have 2, 3, 4, and that's your input value. You're inputting 1, 2, 3, 4, and your output, say A, B, C, is gonna have different values. So no two values are gonna end up being the same. But the thing with many-to-one mapping you get the idea, but this is our input, output. So we'll have, let's say, 5, 6, 8, and just try ABC again for output. Maybe 5 will give you an output of A, and 6 will also give you an output of A, and 8 gives you an output of B, and let's just say there's no C, let's just say there's only B for this example. So you could see that two of the inputs have the same output, which makes it many-to-one mapping. There's more than one. Versus one-to-one, there's literally one for every input. There's one unique output. There's one different output. There's no same. Okay? So just to go over an example, let's do a basic one. Let's say you have y of t is equal to x squared of t. So we'll have to do a chart. X of t and y of t. And let's say we plug in -3. Well, after plugging in -3 to x squared of t, we'll get 9. Okay? But let's say we plug in 3, we'll also get 9. So there's many-to-one mapping, which means this system is invertible. Or no, it's non-invertible, my bad. Non-invertible. Since it follows many-to-one mapping, it is non-invertible. And let's just go over another example. Let's say you have y of t is equal to x of t plus 2. Let's draw a table. So let's say we plug in for x of t, let's say we plug in 1, we'll get 3. 1 plus 2 is 3. Let's say you plug in minus 1. Minus 1 plus 2 is 1. And let's say you plug in minus 2, you get 0. And you can kind of see, let's say you plug in 0, you'll get 2. You can see that we're getting different. For every input, we're getting unique outputs. There's different outputs for every input. So this system is invertible since it follows one-to-one mapping. However, this can get a little complicated because sometimes you don't even have to plug in numbers. You could plug in like the direct delta function, or you could even plug in u of t, which could make it a bit annoying. So I might go over examples for that, but I just want to give the general idea of what's going on. So yeah, that's how you check if it's invertible or not invertible.